Hi everyone, it's Hiral Shah and let's start with our previous session which was incompleted. And previously we did one topic. We were doing harmonic functions and we practiced I think 6 to 7 examples and continuing with the same procedure and hope you all did previously all the examples that we did in our last sessions. So let's start guys our today's sessions. And the question is given, show that del square upon del x square plus del square upon del y square equals to 4 into del square upon del z into the del z bar. See guys, these all are the examples is based on the formulas only, and there are total 4 types of examples. I mean related to these questions, there are except this there are 3 more examples. So 2 examples I'm going to conduct, and rest of the 2 examples you have to write as an assignment. Okay, and these all examples are very much important because one is coming in the exams either into 4 or into the 7 marks. So please keep attention guys. Now see, here you have to prove LHS equals to RHS, and here you can see that there are given 2 components Z and Z bar. So, and you know the values of Z and Z bar, right? So first of all I am using with the condition Z equals to x plus iy and Z bar equals to x minus iy. Now I'm finding its real components and imaginary parts, right? It means x and y, real parts of z yani ki x and real imaginary parts of z yani ki y. Okay, so the x will be z plus z bar upon 2 and the y will be z minus z bar upon 2y. Okay, now I'm going to find del f upon del z, and then after we will find for the next component. uh, Now del z upon del z, del f upon del z, this one I'm writing in the form of, in the term of x and y. So we can write del f upon del x into the del x upon del y plus del f upon del y into the del y upon del z. It means this one z I'm writing in the form of x as well as in the form of y. Okay, now del f upon del x I'm keeping as it is, and we have the values of x with respect to z. Of course we all having x yani ki real parts of z. So the x with respect to z definitely we can do, and the answer will be 1/2, and y with respect to z, so that will be 1 upon 2y. Okay, so from this both the terms taking common 1/2, so that you can get del f upon del x plus 1 upon I del f upon del y term. And same part we will do for the next term. This one is being multiplying by, as you know all, LHS equals to RHS. You need 4 into the del square f upon del z into del z bar. We need 2. So I am multiplying 2. So that this one will be 2 into del f upon del z equals to del f upon del x plus 1 upon I del f upon del y. So I just did the cross multiplication of this, so that we can make a subject of 2 into the del f upon del z. Now same we will do for the next component. This is for the z bar. So with the same procedure only, del f upon del z bar. So this one again we will write in terms of x as well as in terms of y. So del f upon del x and del x upon del z bar plus del f upon del y into del y upon del z bar. And again we all having a value of x with respect to z bar and same y with respect to z bar. And the x with respect to z bar you can get 1 upon 2, and y with respect to z bar you can get minus 1 upon 2y. I hope you all know the derivative of x and y with respect to z bar, because this one I'm going to write directly. And now taking out the common 2, so it will be 1 upon 2 into the bracket del f upon del x minus 1 upon I del f upon del y. And now with the same equation number 1, I'm just shifting these two in the numerator. So doing cross multiplication, 2 into the del f upon del z bar equals to del f upon del x minus 1 upon I del f upon del y. So this one I am saying equation number 1 and 2. Why this one I have multiplied by 2 here? Because you need into the RHS as a 4 form. Okay. So now from the equation number first and the second we can write, I'm just doing the multiplication of these both LHS and RHS. So I'm just doing the multiplication of these both the terms. So from first and the second equation we can write these 2 into the 2. So it would be 4, right? Now del f upon del z multiply by del f upon del z bar. Okay, and so that we can write multiplying these both the terms into the partial differential equation, we can denote it as del square f upon del f into del z bar. Okay, so multiplying these both the terms you may get this term. I hope you all understood guys. And equals to सी गाइज, अगर आप लोग ये नहीं लिखोगे तो चलेगा. दिस वन इज नो नीड टू राइट. So I'm just giving one easier step. Okay, so see, we have multiplied these both the terms. So similarly, of course, at the RHS also we will multiply these both the terms, right? So this one will be del f upon del x plus 1 upon I del f upon del y into the other bracket, यानी कि this one multiply by this one component, and this one I have written here. You can observe this guys. Okay, so multiplying these both the terms, now opening the brackets here, may you get 4 terms, but the 2 terms will be cancelled out because one term will be into the positive sense and the another one will be into the negative sense. So the rest of the equations components will be del square f upon del x square plus del square f upon del y square. So hope you all understood guys. Now moving forward for the next example, and here I have written the 11th example, and the question is given: if f of z equals to u plus iv is analytic into the domain D, then prove that one condition is given that del square upon del x square plus del square upon del y square equals to into the mod of real parts of f of z whole square equals to 2 into the mod of f dash of z whole square. Okay, so again we will do with the same procedure of 10th example. Let's start. You can observe that here it's given 2 components. In the 10th example it was given z and z bar, and here it's given f of z and f dash z. Okay, now we all having a formula of f of z, and this one will be u plus iv. Okay, now here already it's given that f of z is an analytic function. So since this one f of z is analytic, from the analytic we can write u and v both are harmonic functions, because this one theory we just did in our previous sessions. So if we can write u and v are harmonic functions, then we can write 2 conditions for the harmonic functions. First one is for the u, and the second one is for the v function. So for the u functions we can write del square u upon del x square plus del square u upon del y square equals to 0, and for the second component yani ki v, del square v upon del x square plus del square v upon del y square equals to 0. Okay, so in the very first part, what we did, it's given f of z is analytic, and from analytic we can write the given function will be harmonic. So we can say that u and v both are harmonic functions. So there are conditions for some for these both specific functions components. So for the u we have written uxx plus uyy equals to 0, and for the v also vxx plus vyy equals to 0. And also we can write f dash z equals to del u upon del x plus I del v upon del x, as we were finding in our previous sessions. जो हम z f dash की जो formulas लिख रहे थे वो मैंने यहीं पे लिखा है, ठीक है. So now from this f dash of z we can write its mode also, right? Because as you know the equation, and from the equation you can you have to find its mode also, right? So I'm finding its modulus. So this one will be the under root form, like mode z will be under root of x square plus y square. If you are not getting, then I'm writing here the mod z equals to the under root of x square plus y square. Okay, so based on this formula I have written f the mod of f dash z. So it will be the under root of del u upon del x whole square plus del v upon del x whole square. Now starting with the LHS part, so I'm writing this and the real parts of f of z. So f of z हमारे पास already है, that is in the form of u plus iv, and as you know all the real parts of f of z यानी कि u plus iv में से हमें सिर्फ क्या लिखना है, उसका real parts. तो उसका real parts क्या होगा, u square. So here I have written here u square. Now multiplying, now opening these brackets, so multiply by u square on both the terms. So del square upon del x square into the u square plus del square upon del y square into the u square. Now see, two times you have to do the derivative. So first single components I am writing as it is, like del by del x, and I'm just doing one derivative of u square. So it will be 2u del u by del x, right? Plus del upon del y into the, again with the same procedure, here I will write I'm just opening a single derivative, so it will be 2u into del u upon del y. Okay, now again one more derivative is remaining, right? And from this both the terms you can observe this 2 is common and u is common. So just doing the second derivative now, so that you can get here u as it is. Okay guys, let me clarify. Here we are doing multiplication rule, right? Because you can see that 2 is common for all, and the remaining term will be here u into the del u upon del x. Okay, so with respect to x we are doing, so u as it is, del u upon del x का होगा del square u upon del x square plus again the second term as it is, and u का होगा del u upon del x. So it will be del u upon del x whole square. I hope you all understood guys. And same for the second one. two हम लोगों ने already यहाँ पे common निकाल दिया है. So the remaining term will be u into the del u upon del y, and this one we will do again with respect to a similar term with respect to y only. So u as it is, यानी कि first term as it is, second का derivation. So second का होगा del square u upon del y square plus, now second as it is यानी कि del u upon del y as it is, and first का होगा यानी कि u का होगा del u upon del y. So this one will be del u upon del y whole square. Okay, so I hope you all understood guys. Now next, I'm just separating the terms. So u as it is, and from first and the third, I'm highlighting, guys. Okay, from this one and this one, I'm just taking out the common u. The into the bracket, the remaining term will be del square u upon del x square plus del square u upon del y square plus यहाँ पे जो दो टर्म है उसको एज इट इज हम लोग यहाँ पे लिख रहे हैं. सो डेल यू अपॉन डेल एक्स होल स्क्वायर प्लस del u upon del y whole square, right? Okay, so now by using equation number 1 as we have written into the previous slides, so in place of that we can write this. So therefore del u upon del x whole square plus del u upon del y whole square. So by using the equation number 1, finally we can write this one term, and this one is nothing but the these equations, because if we will do this one whole square, अगर इसका हम लोग स्क्वायर करें तो फिर क्या होगा, ये रूट्स निकल जाएगा, ये रूट, राइट. सो सेम एज इट विल बी द नॉर्मल फॉर्म ऑफ दिस, यानी कि डेल यू अपॉन डेल एक्स होल स्क्वायर प्लस डेल यू अपॉन डेल वाई होल स्क्वायर, दिस वन इक्वल्स टू, वी कैन राइट दिस वन, यानी कि 2 into the mod of f dash of z whole square. So hope you all understood, guys, and from these two examples I'm giving you more two examples, and the question is given right now. The question is, if f of z is analytic function of z, then prove that the condition is given. See guys, this one is important example. Del square upon del x square plus del square upon del y square into the mod f of z whole square equals to 4 into mod of f dash of z whole square. In same you have to do for the 13th example, and these both examples you have to write in your assignment books and have to submit. So hope you would like my today's session. uh, we will start a new method. Thank you guys.